3D geometry or three-dimensional geometry involves the study of shapes and figures in a three-dimensional space. Unlike 2D geometry, which deals with the flat shapes like squares and circles, 3D geometry includes objects that have depth such as cubes, spheres, and pyramids. Here are some key concepts in 3D geometry. Any point in 3D space is represented by three coordinates x, y, and z, corresponding to its position along x-axis, y-axis, and z-axis. Just like in 2D geometry, you can have lines and planes in 3D. A plane can be defined by a point and a normal vector, while a line can be defined by 2 points or a point and a direction vector. Common 3D shapes include cubes, spheres, cylinders, cones, and pyramids. These shapes have properties like volume and surface area. 3D geometry is widely used in fields like computer graphics, engineering, and physics, to name a few. Theory of 3D geometry starts with representing a point in 3D space. To represent a point in 3D space, we need three independent dimensions that uniquely defines the location of the point. These three independent dimensions are called coordinates. There are three types of coordinate systems in use: Cartesian, cylindrical, and spherical. In Cartesian coordinate system, we have three mutually perpendicular vectors called axes. These axes are named x, y, and z axis. The coordinates of the point are represented using x, y, and z coordinates. If an object is in cylindrical shape, it makes more sense to use cylindrical coordinate system. In this system, a point is represented using radius r, angle theta, and height g as shown in the diagram. To model objects that are spherical in shape, spherical coordinate system is used. In this system, radius r, angle phi, and theta are used as shown in the diagram. Coming back to Cartesian coordinate system, if we have 2 points, say P and P1 in the space, the distance between these 2 points can be calculated using standard formula d equal to square root of x minus x1 square plus y minus y1 square plus z minus z1 square. This equation can be proved using geometric formula and Pythagoras theorem. Suppose we have a line AB and there are 2 points A and B on this line. The line AB is divided in the ratio m:n. If we know the coordinates of the points A and B, then the coordinates of the section point P are given by x equals mx2 plus nx1 whole divided by m plus n, y equals my2 plus ny1 whole divided by m plus n, and z equals mz2 plus nz1 whole divided by m plus n. If there is a vector A represented as A equal to ax plus by plus cz, where x, y, and z are unit vectors along x, y, z axis respectively, then A, B, and C are components of the vector along x, y, z axis, and they are called direction ratios. Put in simple words, direction ratios are components of a vector along x, y, and z axis. On similar lines, if the vector makes angle alpha, beta, and gamma with x, y, z axis as shown in the figure, then cosines of these angles are called direction cosines. Direction cosines are often denoted by L, M, and N, where L equals cosine of alpha, M equals cosine of beta, and N equals cosine of gamma. Note that direction ratios and direction cosines are related to each other. If we know direction ratios, we can calculate the direction cosines and vice versa. Let us have two vectors u and v with their direction cosines L1, M1, N1 and L2, M2, N2 respectively. Then the angle between these two vectors is given by cos theta equal to L1, L2 plus M1, M2 plus N1, N2. Let us consider a line in Cartesian coordinate system passing through a point U having coordinates x1, y1 and z1. If AB and C are direction ratio, then the equation of the line is given by x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C, as shown in the diagram. It is also possible to represent a line in a vector form as well. If the line has position vector A and direction ratio given by vector B, the position is represented as A plus lambda B, where lambda is a scalar. If there are two intersecting lines U and V with direction cosines L1, M1, L1 and L2, M2, N2, then the angle between these two vectors is given by cosine of theta equal to L1, L2 plus M1, M2 plus L1, M2. Similarly, two intersecting lines U and V with direction cosines A1, B1, C1 and A2, B2, C2, then cosines of the angle between them is given by a lengthy formula as shown in the diagram. Two lines are said to be skewed if they are not intersecting and they are not parallel to each other. However, a vector normal to both skew lines can be found, and distance between the intersecting points of this normal vector is the shortest distance between skew lines. Angle between skew lines is not well defined because they do not intersect. The shortest distance between two skew lines is the perpendicular distance between them. The formula to calculate the shortest distance between two skew lines is given by the formula as shown here. If we have 2 points A and B whose coordinates are x1, y1, z1 and x2, y2, z2 respectively, then the equation of a line passing through these 2 points A and B is given in the figure. To find equation of a plane in 3D space, first define a normal vector to the plane, then the normal vector be n and A, B, C are direction ratios of the normal. Then consider 2 points P, O and P on the plane. Then the vector POP lies on the plane. This line is also perpendicular to normal vector n. Applying the condition that normal vector and vector on the plane are perpendicular to each other, then their dot product should be 0. So we kept the equation of the plane. If the plane makes intercepts A, B and C with x, y, z axis respectively, then the equation of the plane is given by x by A plus y by B plus z by C equal to 1. If a normal to a plane has direction ratios A, B and C, and D is the distance from the origin, then the equation of the plane is given by AX plus BY plus CZ plus D equal to 0. Based on this theory, we shall solve some questions. The first question is, in 3D geometry, a point P is represented by the coordinates x, y and z. If P is located at location 3, -2, 4, which of the following statements is true? These coordinates represent the distance of the subpoint from the respective axis. So a point 3, -2, 4 means that the point is 3 units away from the y-axis, 2 units away from the x-axis and 4 units away from the z-axis. Therefore, the correct answer is option 1. Question 2 is, consider 2 points A and B in 3D space. What is the distance between these 2 points? Use the formula distance between 2 points and substitute the given values. Option 2 is correct too. Question 3 is, in 3D geometry, the coordinates of a point P dividing the line segment joining 2 points A and B in the ratio 2:1 internally are given by which of the following options? Use section formula in 3D geometry. Option 3 is correct. Question 4 is, consider a straight line in 3D space passing through the point A and parallel to the vector B. Which of the following options correctly represent the equation of this line? Use the standard formula equation of a line in 3D space passing through a point and parallel to a vector. Question 5 and 6 are for practice. Please watch the second part of this video, which will be continuation of 3D geometry. Thank you for watching.